Okay, I started this integral in class. I'm going to do the whole thing out here. I'll take my time. I might pause a couple times to make sure everything works out correctly. So what we're going to do is we're going to integrate the volume. And so for the volume, we have to recognize that our function is going to equal 1 at all points. So we're going to look at the volume as some volume element of 1. And so this was number 37 in our textbook, which just asks to set it up, but we're going to find the full volume element from it. So we're going to set up the integral for the region D, which is the right cylinder, whose base is the circle r equals 2 sine theta, which is in the xy plane. And whose top is in the plane z equals 4 minus y. So again, I think I'll still like going with red here. Draw my axes. I'll start with my x-axis. And my y-axis. And my z-axis. There we go. So there's x. There's y, and here is z. All right, so we're first going to look, I guess I'll need to extend back this way also. Whoops. Trying to hit my tool here. There we go. And so let's look at this region, the r equals 2 sine theta. So when theta is 0, I'm pointing down the x-axis, and I'm at 0. When theta is at 30 degrees, so 30 degrees is off this way, I'm going to be at 1. When I'm at 90 degrees, or pi over 2, I'm going to be at 2. When I'm at 150 degrees, let's see, there, going to, oops, that's not a radius of 1, that's a radius of 1 at 30 degrees is, what is 1 projected into x? 30, that would be root 3 over 2, and root 3 over 2 is about 0.8 and about a half. So at 30 degrees, I'm about here. At 90 degrees, 1, 2, 3, 4, I'm here. At 45 degrees, what am I? Root 2 over 2. So that's root 2, which is 0.7. So this circular region, it's a little wide. I hate drawing 2D perspectives. I'm not the best at it. See, 1, 2, 3, 4. That'll be out 2. And then 2, 1, 2. There's my circular region that forms the base of this in the xy plane. So there's the base of the circle. Then this rises up in z. So I'm going to put some of these parallel to the z-axis, just so I have some markers. And then what I'm going to need here is I'm going to need to figure out how high up this is when y is 0. And that's going to be at 4. So I'll come up this axis at 4. Here. And then when I'm over here, when y is equal to 1, this will be at 3. Over here it'll be at 3. And then when y is 2, this will be down to 2. So I have this kind of downward cut shape here as the top surface. And so I'm ready to set up my terms of integration. So I'm going to take some point inside my region down below, and I'm going to puncture that region through I'm going to puncture a ray from that lower region up. And I have to ask myself, when does it enter? Well, it enters at z equals 0, and it leaves, popping out here, at z equals 4 minus y. But y is not in cylindrical coordinates. So I have to use the transform on y and have 4 minus, well, what is y? Y is r sine theta. So I guess I have the first part of my integral set up here. I have z equals 0 to z equals 4 minus r sine theta. All right, and now I need to take an element from the origin and pass it through where I projected into my figure, the projected region. And I have to ask myself, when does it puncture into here, and when does it puncture out of here? And so this point is r equals 0, and it leaves at r equals, well, this figure, because anywhere on this figure, and that's 2 sine theta. So my next limits of integration are r equals 0 and r equals 2 sine theta. And then I have to think about what angle I'm rotating through, and this entire figure takes 0 to pi to rotate. And so now, since I'm doing a volume element, I have my function is 1 times r dz dr d theta. So I have my integral set up, and we can work on solving this integral. So I'm going to pull my space down and focus on this integral. So I'm going to integrate the first part. I'm going to integrate in terms of z. So I still have 0 to pi. That pi looks a little weak. Then I'm going to have r equals 0 to r equals 2 sine theta. And then I'm going to go from, and I've integrated this in terms of z, so that's rz, evaluated from z equals 0 to z equals 4 minus r sine theta. So I will now substitute in. What's nice about the 0 component is with the fundamental theorem, I don't have to do the subtraction. So I'm from 0 to pi. Then I'm going to evaluate from r equals 0 to r equals 2 sine theta. And I'm going to have r times 4 minus r sine theta. And that's dr d theta. I'll distribute. So that's going to be 4r minus r squared sine theta, dr d theta. And now I'll integrate within terms of r. So 4r becomes 2r squared, right? This is going to become r squared over 2. That's going to cancel out there. And then this is going to become r cubed over 3. I'll make it 1/3 r cubed sine theta. And we're going to evaluate this from 0 to 2 sine theta with a d theta coming at the end. So continuing on, I'm going to have 0 to pi, and now I'm going to replace in. So I'm going to get 2 times 2 sine theta squared minus 1/3 2 sine theta cubed times sine theta. And if I do the zeros, there's nothing on the 0 side again for the fundamental theorem, so I'll have d theta out here. So I'm going to have 2 times 4 sine squared theta minus 8 sine cubed theta, but that cube is going to be times this sine, so sine to the 4th theta, d theta. And just a little bit of cleanup here. In fact, what I think I'm going to do is to clean this up a little bit more, I'm going to pull the 8 out front. All right, because that's going to be an 8 sine squared theta minus 1/3 sine to the 4th theta, d theta. And now I'm going to use some power reduction rules. So I'm going to work with the fact that sine squared theta is equal to 1 minus cosine 2 theta over 2. And cosine squared theta is equal to 1 plus cosine 2 theta over 2. And hopefully that'll help us clean these things up a little bit. So let's see, I'm still going to have my 8 outside, 0 to pi. And so I'm going to have 1 minus cosine 2 theta over 2. Whoops, all over 2. Minus 1/3. Well, this is sine squared theta squared. So I'm going to have 1 minus cosine 2 theta over 2 squared d theta. And let's see, this has a half, so I'll pull this half out front. And so this will give me 1 minus cosine 2 theta. And if I do this squaring, that's going to be a 4th underneath, so I'm going to pull that 4 out front. So that'll be a 12th. And upstairs I'm going to have 1 minus 2 cosine 2 theta plus cosine squared 2 theta, d theta. Whew, this is expanding out weirdly, but hopefully we'll get to where we need to go. It's going to leave my 8 out front. I'm going to have a 1/2 here. 1 minus cosine 2 theta 1 minus 1/12, 1 minus 2 cosine 2 theta, and then plus, well, this is 1 plus cosine 2 theta over 2. And so now I just have cosine 2 thetas and constants. So I'm going to collect like terms. So this is going to be 1/2 minus 1/2 cosine 2 theta. So I distribute that through. Then I'm going to distribute this negative 1/12 through. So it's going to be negative 1/12 plus 1/6 cosine 2 theta. And then this is going to be a minus. And so the minus is going to be negative 1/12, or 1/24, sorry. And then, do I have my cosine theta and sine thetas backwards? I might have to do a little checking here. Let's look at my distribution here. Let's see, so cosine 2 theta is equal to cosine squared theta minus sine squared theta. So cosine 2 theta is equal to 1 minus sine squared theta minus sine squared theta. So that's going to be 1 minus 2 sine squared theta. So that'll be 2. No, that's right, that's the minus cosine, and that's the plus. So the negative comes through here. Negative, positive, okay. Negative, I'm just trying to make sure all my signs are in the right place. 1 minus this squared is a plus sign there. That works. And so I'm going to have negative 1/24, right, because that's 1/2, minus 1/24 cosine 2 theta, d theta. Let me just double check my expansions. That's negative 1/12 plus 1/6 cosine 2 theta minus 1/24 minus 1/24 cosine 2 theta. All right, so I'll collect like terms. So I'm going to have a 1/2 minus 1/12 minus 1/24. And then I'm going to have minus 1/2. Well, let me. Uh-oh. Where did it go? It all went away. Let's see. Let's edit undo. There we go. Didn't mean for everything to disappear. Let's see here. Get rid of that 1/2. All right, so I gathered my constants, 1/2 minus 1/12 minus 1/24. And now I'm going to gather minus 1/2 for this, plus 1/6 minus 1/24 cosine 2 theta. D theta. I think the hardest part is our coefficients here. So 24 is the best thing to have here. So this is 12 minus 2. So 12 minus 2, this is 9/24. Plus, again, 24 is the best thing to have here. And so this is 4 minus 12 minus 8 minus 9/24 cosine 2 theta d theta. Oh, and now I can integrate. Let's see, divide both by 3, so that's 3/8 theta minus 3/8 sine 2 theta, and I'm going to get a 2 down here, so we'll just put times 2, evaluated from 0 to pi. So I'll put my pi's in, so I'm going to get 8 times 3/8 pi minus 3 sine 2 pi minus 3/8 times 0 plus 3 over 2 times 8 sine 0. Well, that's 0, and that's 0, and that's 0. The 8's cancel, and so I get 3 pi.